Okay, in this video we'll learn about reverse percentages and in particular increases and decreases. So we'll learn two formula. The first formula is the reverse percentage increase formula. Now essentially if we're given an amount A and we're told that it's the result of some percentage increase, say X percent, then if we need to find the initial value of that amount, in other words, the value it was before it was increased, this is a typical reverse percentage problem. And in this case, we use the reverse percentage increase formula, which is shown here. Now you'll want to make a note of that formula. We're going to see a couple of examples afterwards. Similarly, we'll often be asked to do the same thing, but in the case of a reverse percentage decrease. And so once again, we'd be given an amount A, and we're told that that amount is the result of a percentage decrease, again, say by X percent. Then the initial value or amount A is found using the reverse percentage decrease formula, which is shown here. Now that we've said that, let's go ahead and work through a couple of examples to see how we use these formula. So we're told that at the age of 16, Michael weighed 68 kilos, and that was 15% more than what he weighed when he was 13 years old. How much did Michael weigh when he was 13? Now this is a typical reverse percentage problem. We can see that we're given a weight, 68 kilos, and we're told that that is a result of a 15% increase. In other words, we have to find how much he used to weigh before that increase took place. So to do that, we use our reverse percentage increase formula, and we write the following. A initial times 1 plus x over 100 equals to A. Now in this case, A initial is what we're after. We're trying to find that. That's how much Michael weighed when he was 13. X is the percentage by which that weight was increased, so that's 15. And A is the amount he weighs now, so that's 68. So let's go ahead and replace all those. We can say A, and I'll just write AI for A initial, times 1 plus 15 over 100 equals to 68. That leads us to AI times 1 plus 0.15 equals to 68, which leads us to AI times 1.15 equals to 68, which I can write without the parentheses, leading us to AI times 1.15 equals to 68. So now to find the initial weight, we divide both sides of this equation by 1.15. That's AI, the initial weight, equals to 68 over 1.15. And now using a calculator and rounding to two decimal places, we find 59.13 kilograms. Now it's unlikely that we need to go to two decimal places here, so we'll just round to the nearest kilo and say that Michael used to weigh 59 kilograms. And there we have it. That's how we solve that reverse percentage problem. Let's look at one more. In this case, we're told following a 30% decrease in price, a t-shirt costs 28 euros. And we're asked what was the t-shirt's original cost. Now once again, this is a typical reverse percentage problem. The only difference here is that we're dealing with a percentage decrease. So we use our reverse percentage decrease formula. And we can go ahead and write A initial, so that's A initial, times 1 minus x over 100 equals to A. Okay, that's where we start. Now in this case, A initial is what we're after again. That's the price of the t-shirt before its price was decreased. X is the percentage by which it was decreased. So in this case, it's 30. And A is the cost of the t-shirt today, so that's 28 euros. So replacing all the values we can, we find A initial times 1 minus 30 over 100 equals to 28. Carrying on, we have A initial times 1 minus 0.3 equals to 28. And 1 minus 0.3 is 0.7, so we have A initial times 0.7 equals to 28. Getting rid of those parentheses, we have A initial times 0.7 equals to 28. And now we're all set. All we have to do now is divide both sides of this equation by 0.7 to find the initial cost. So let's go ahead and do that. A initial equals to 28 divided by 0.7. And we find that's equal to 40. So the original cost of the t-shirt was 40 euros. And there we go. That's how we solve reverse percentage problems. I hope that helps.